In our previous lessons, we've looked at series-to-series arithmetic operations, and we've also looked at data-frame-to-data-frame arithmetic operations. But this time we're going to explore operations between a data frame and a series and how that works. And in order to illustrate that, we're going to use an NP array with the shape of 3 rows and 4 columns. Let's output that. And from this array, we're going to extract this first row. So that should be 0, 1, 2, and 3. Now the default behavior of a NumPy arithmetic operation is going to be row-wise, which means if we subtract this row from this array, the operation will occur first across this entire row, zeroing it out, right? So 0 minus 0 is 0, 3 minus 3 is 0, and likewise for these two values. And then it'll move to the second row, so it's row-wise. Well, 4 minus 0 is 4, and 5 minus 1 is 4, and 6 minus 2 is 4, and likewise. By the same logic, this row will all be 8s. So let's perform that operation. And what we're illustrating here is that, by analogy, if this was a data frame, and if this was a series, the default row-wise behavior we observe in NumPy is inherited in the Pandas library. And this means that the indices from a series are going to match the rows from a data frame. Let's run this data frame here, and let's run this series and inspect them. And the way we constructed this is that we have 2 rows that match with 2 of the indices, and then we have a C row here that does not match with any index in our series, and a E index which does not match with any row in our data frame. And if we perform an operation on this, what's going to happen is a union will be formed. So we'll have columns A, B, C, and E, but both C and E will be empties because there's no match between them in the operation. So let's run this arithmetic operation, and we get the union of the rows and columns as we've described, and we get empties in C and E. Of course, if all the columns match, if we change this to a C, and run that again, and then we run this again, all of the rows zero out, the same behavior we observed in the NumPy array. Of course, we recognize from previous discussions about in place that our original data frame has not been altered. And we can perform an operation on this data frame that's analogous to what we did up here with this NumPy array. We can extract the first row from this database. Let's do that. And obviously, the indices from this extracted row are going to match the columns in the original data frame. And when we subtract these from each other, we have the same behavior that we had from the NumPy array. So what's going to happen if we take this S2 series and we re-index it? Let's run that. We have all the same indices, they're just reordered. And let's try subtracting that from our data frame now. And we get the same result because of auto alignment. But when we re-index, if we use a different indice, you'll remember that this creates an empty here. And then if we run this again, we get empties both in C and D as expected. Well, what if we'd like to perform arithmetic across the columns rather than down the rows? So column-wise rather than row-wise operations. Well, very simply, all we have to do is define what axis we're looking for. Rather than grabbing a row from this DF data frame, rather than grabbing this first row, what we'd like to do is grab this B column. Let me output this data frame again so we can inspect the original. And again, we're extracting this first row. So let's do that. And in order to perform the subtraction operation with an extra parameter here, rather than using the subtraction operator, we're going to use this subtraction method. And this should look familiar to you from our previous lesson. So let's run this, and we'll see that we have indeed actually subtracted across the columns now rather than down the rows.